like for this video, we will use EDA Playground to program logic circuits. First, you type into your browser edaplayground.com. So you will see there is a login. Okay. So in this login, you have to log in using your either Google account or Facebook. Okay. I prefer to use, of course, Google here. Alright. Then you have to choose the email address. After signing in, you can see here the testbench tab and the design tab. You can also see the testbench plus design, and we will select Vhdl. Alright. For top entity, the name that you will going to place here or write here is the same as you will write as the title of that program. Okay. So for this program, I will type in problem 1. And the same as to this side, I will type in problem 1. So I will choose private only, you can view. Okay. Then once you hit save button, there is a dialog box that states that please select a valid tool or simulator using tools and simulators menu on the left. Okay. So with that, we have to select Aldec Riviera Pro, right? And then after that, because that's the simulator tool that can be used to run VHDL. Then you have to click on Open EPWave after run, so you can see the output of this code. Okay. And then after choosing the tools and simulators, you have the Aldec Rivera Pro, yeah, there. And then we can now hit save button. Okay. For this case, I will name the test bench as example underscore test bench. So this is the name of example 1 para unique. Okay, so you need to have a unique name so you can't have an error here in EDA Playground. So you copy that one, you copy it here, then you have to use the simulator tools such as Aldec Riviera. Okay, so for this code, so we will now start writing codes in the design part of the VHDL. So we have to write, okay, you have to write library IE. Then you have to use the libraries from this IE where you will going to use the logic circuits operations only. That's why it's STD logic 1164, such as the OR gate, AND gate, NAND gate, and so on. Okay, so we will now write entity space So I have the name of the test bench example 1 underscore test bench. So I will name this as example 1 underscore design. Okay. And then I will write if, and then I have to write the port, then parentheses, I have to write the variables. So where are you going to place, or where are you going to, or what are the variables you're supposed to write? Of course, it depends upon the problem. So in this case, you have letter A, you have letter B, the letter C as an input. So you will write that one, A input std underscore logic, because we will use the operations such as or, and so on. Okay, semicolon. I will copy this and paste it here, but this time this is letter B. Okay, and next is of course letter C. Alright, and then after that you have to place the semicolon after parentheses. Okay, so that's the end of the port declaration. You have to end that with a parenthesis, and the last part should be the semicolon. And after that, you have to type in end, and then what is the name of this design code? So you have to end this design code entity, which is of course sample1 underscore design semicolon. Okay, so let's proceed to the design architecture. So we will write architecture, and then I will write here example 1 RTL, and then you have to connect that in the design entity to the design entity. So you have to type example 1 and underscore design. That's the name. Example 1 design, example 1 design. Then you have to type if, then you have to type begin. You have the process. What should be the process variable? Okay. So you have to use ABC. Alright. So A, B, then C. So that's inside the process. And then, of course, you have to write if. Okay. Then we will write begin. Then after that, we will write the formula F. So your F should also be written here as part of the port. But this time, this is an output logic. F is this one equals to A plus, you have, or I'm sorry, you have to use or, then B and C. But we will write parentheses here to avoid confusion. So B multiplied by C, then you have A or to that operation or operation and okay. So after writing the formula or the logic, okay, logic that you will use here to this problem, you have to end the process, semicolon. Then you have to end the example1 RTL semicolon. So this name came from this. Okay, I think we're done with double check. This is your design, your test bench name. You have to copy this one because we will now write the test bench code. Okay, so you can now save that one. And let's move on to the design test bench code. In writing the test bench code, you have to start with, of course, the library IEE. Use IEE. STD logic is the same as this one. Okay. Again, if you do have two parts of code such as design and then test bench, this library should be the same as this library. Okay. So entity, and then the name of the test bench is example1_test_bench is, and then since we will use this declaration of the operation from the design code, we will leave this as empty, and then we will end this test bench name semicolon. Then we will proceed to the architecture of this test bench TB of course the test bench is and again this is from this one, same came from this C. So let's proceed to the inside code of the architecture. So you have to use component. Then since we will connect that one, you have to write the name of the design code. So what are you going to use is of course example1_design is. Double check. So you have example1, example design is, enter. And then we will type in port, so something like the same as to that part. So what we will going to do is to copy it from there to here. Okay, but of course we have to end, it's not the design name, but we have to end the component. Because component is one of the reserved words. So we can bring this down. Then we will write the signal for all of the variables we already used. Okay, so we will write A, B, C, F, and then of course it's called std_logic semicolon. Okay, so after that we will write already the begin, and then we can write any name for this. Okay, you can write any name for this. This is the legal name, right? For this one I just named it as is DUT. Then you will still need to write the name of the design. So example1_design. Okay. Then fourth map, you have to write all of the inputs. Okay, so open and close parentheses. You have A, inputs and outputs. So something like this is what you call parameters. C, then F. And this is a semicolon. Okay, so after writing that fourth map, so this is still the same from you're declaring or getting all of that input from here and then from here. Okay, then you have to start already the process and then the begin. Then you have to write here all the possible input combinations. So for example, we have 0 for A, the value of A is 0. I can write B as 0 2, then I can write C as 0, but the end of that is always wait for 1 nanosecond, which in this case the final output is a waveform, which in every cycle there's a specific time. So that's for one. For example, the one cycle is, or one cycle is equivalent to 1 nanosecond. Okay. So after that, I can write another input combination 0001, and then another one. Let me have 1000, 100, and then end is wait for 10 nanoseconds. And for the last part, I will write wait semicolon, and then I will end this process semicolon, and I will end this test bench or TD, which is of course the name is came from this, because this is the entity end, this is the architecture end. Semicolon, and let's save it. Then you can run. Alright, so if you do have error, you have to debug it. Line number 19, ACF colon. Okay, what's missing here is colon. Then you have to save again. Then you have to run. Okay, so you can see now the output from this. You can see the value. Of course, you have 001 for ABC, 001, BC is 0 and C is 0, plus of course if A is 0, your F is 0. Okay, and then of course, if you happen to have, okay, so let's something like edit a code. For example, I have one input for A, just like this. Alright, so let's run this one again. Okay. If the value of your A is 0, you have 0. But if you do have 1, the value of your A is 0 pa rin. If you have 1 value for A, definitely you have the 1 output. Okay? So you can change this to hex or binary. But since you only have these values, it's only the same. Alright? So with that, thank you so much for listening.